Decentralized finance primitives are the fundamental building blocks that compose more complex financial applications. These primitives include basic operations such as deposits, withdrawals, swaps, loans, and collateralization mechanisms. They serve as standardized components that can be assembled in various configurations to create sophisticated financial instruments. The concept of primitives is significant in DeFi because they enable composability, the ability to combine different financial elements into new applications. This modular approach allows developers to create complex financial products without rebuilding basic functionalities. It also promotes security through reuse of well-tested components rather than implementing critical functions from scratch each time. The Marlowe Playground's integration with Blockly aligns particularly well with this primitives-based approach. Blockly's visual programming environment represents code as interconnectable blocks, which mirrors how financial primitives function in DeFi systems. Each Blockly module in Marlowe corresponds to a specific financial operation or contract element. This structural similarity between Blockly's design and DeFi primitives creates a natural mapping. The visual nature of Blockly makes the abstract concept of financial primitives more tangible. Users can manipulate these blocks to assemble contracts, seeing exactly how primitives combine to form complete financial instruments. The Marlowe implementation also includes validation at the primitives level, ensuring that the building blocks themselves maintain the safety properties required for financial contracts. Marlowe may have some limitations for consumer apps or use in DAOs, but for DeFi from primitives it fits perfectly. Let us look at an example how to construct Marlowe code based on known primitives. As an example, let us consider a convertible bond. What we are trying to achieve is an ADA time deposit that returns more than the initial investment. If certain conditions are met at the end of the holding period, for example, the asset price of our native protocol token has fallen below a NOK in price, the investor would receive the token instead of ADA. We know that apart from the convertible feature, this is identical to a zero-coupon bond. For the final choice, whether to receive ADA or the other token, we can reuse the logic from a contract for difference contract with Oracle. Instead of making this choice based on price boundaries, who will get paid, a choice is made of the asset returned to the creditor. Instead of writing the whole contract from scratch and potentially using unsafe logic, or incurring high development cost, we insert code blocks and change only the parts that are unique. Options available, for example using native tokens, can easily be selected from the menu.